Hey guys, welcome to question FM272 of the Further Maths Fortify study guide. This question reads, 5 workers, Addison, Beck, Carly, Dylan and Evan, are each to be assigned a different task by their boss. The table below shows the time in days that each worker would take to complete each of the 5 tasks. And then we're given a table, a little different looking to this one, but essentially the same information. Then goes on to say, the boss wants to allocate the jobs so as to minimize the total time taken to complete the 5 tasks. After finding the most effective allocations, the boss finds out that 2 outcomes are possible. If each worker starts their job at the same time, then the first worker to finish could be, and then we're given 5 options. So, the first step in a Hungarian algorithm is to do a row reduction. So we're going to start off by taking the smallest number from each row and minusing it from all of the other numbers in that row. So in this first row, our smallest number is 6, so we're going to minus that from each of the others. Now I'm not going to label A, B, C, D and T1 through T5 at each step, so I'm just going to make the grid of numbers. So here, when we remove 6 from each of the numbers here, we're going to get 0, 3, 3, 1, 6. In this second row, 5 is going to be the smallest time, so we're going to remove 5 from each, leaving us with 3, 0, 0, 6, 2. In this third row, the smallest number is going to be 6. Removing that, we get 0, 3, 2, 4, 2. In this second last row, 6 is the smallest, so we're going to get 3, 0, 0, 1, 4. And in this final row, the smallest number is 7, so we're going to get 1, 2, 1, 0, 0. Now we look through each of our columns and make sure each of them has at least 1 0, which they do. And now we're going to do a line test, so we want the minimum number of lines required to cover all of the zeros to match the number of tasks to be allocated. So because we have 5 tasks, we want the minimum number of lines to be 5 also. However, you'll see quite quickly that we can cover all of the zeros using only 4 lines, which means we're not quite done yet. So I'm going to take this up here. Now, what we're going to do is take the smallest uncovered number. So it's out of the 3, 3, 1, 6, 3, 2, 4, 2. So our smallest uncovered number is a 1. And we're going to minus that from every uncovered number and also add it to every number that is crossed with 2 lines. So we're going to add it to the 3, the 3 and the 1. We're also going to leave these numbers that are crossed by only 1 line, we're going to leave those alone. So going through, we should get 0, 2, 2, 0, 5. We should then get 4, 0, 0, 6, 2. We should get 0, 2, 1, 3, 1. We should get 4, 0, 0, 1, 4. And we should get 2, 2, 1, 0, 0. You'll now see that by adding in this 0, it is going to take us 5 lines, either adding 1 in here or 1 in here, in order to cover all the zeros, which tells us that we're done. So minimum number of lines would be 5. We've got 5 tasks to allocate. That's how we know that we're done at this point here. So now we're actually going to create what's called a bipartite graph. So we're going to set up the tasks and the people. So we've got A, B, C, D, and E. We've got task 1, task 2, task 3, task 4, and task 5. So if we were to just remind ourselves here what they are, we're going to create connections between names and tasks based on where we see zeros. So for example, going down A's column here, we see a 0 at task 1 and at task 3, meaning that we can connect task 1 and task 3 with A. When we go to B, we see it's connected to task 2 and task 4. With C, also connected to task 2 and task 4. D is connected to task 1 and task 5. And E is connected to task 5 only. So now we're going to look at possible allocations. Now E must complete task 5 because it's the only one that he's able to do. From here, that means that because task 5 has been taken, D can only do task 1. And now because task 1 has been taken, A can only do task 3. What you will notice, however, is that the 2 tasks left over, task 2 and task 4, can both be completed by either Beck or Carly, options B or C. So we are going to end up with 2 possible allocations here, just like we were told we would. So our possible allocations are D with T1, B with T2, A with T3, C with T4, and E with T5, or D with T1, C with T2, A with T3, B with T4, and E with T5. So the difference in our allocations here is that either B or C is completing task 2, and either B or C is completing task 4. Those are the only 2 that we've swapped. Now the question actually asks, if each worker starts their job at the same time, then the first worker to finish could be who? Now, if we look at these possible allocations, A is set on task 3, B is on either 2 or 4, C is also on 2 or 4, D is set to task 1, and E is set to task 5. So depending on who has task 2 out of Beck and Carly, that will be the person who finishes first, because task 2 only takes 5 days, all of the other activities take 6 or 7 days. So whoever completes task 2 is going to be the first person to finish, and that could be either Beck or Carly, which means the answer to this question is option E, Beck or Carly. If you guys have any questions about that, please drop them in the comments below. Otherwise, I'll see you in the next video.